Good morning, early morning hustle. Let's go ahead and go ahead and start with this. So I'm gonna open up Posit, okay, Positron, and so look at this and note where I am, okay, and then I'm gonna go to open up the project, okay. So now I should have my files here accordingly. So this is the last of the series, at least the 4 video series. I believe I'm almost certain I have another one for you all, which is kind of cool. Just another video within the series, but it's an ad hoc, it's an additional one because this per package is not only just really important to me, it's really important in general. It's very it has a lot of perks that allow you to bring in clean data in more efficient ways and not using for loops and things of that regard. So we already know what a for loop is because that's what we talked about in video 9. Control structure and conditional logic. We've seen this before. And then we also talk about functions. So in some weird shape or some weird thing, I don't want to say that, but in this weird way, we're going to combine all those concepts here using the per package. So to more iterations of functional programming. All right, so the package is called purrr. The 3 R's are, I don't know why it's called purrr. Put it in the comment. Why is it called purrr? ChatGPT it or something. Purrr. And I believe you should automatically have it installed because it's part of the tidyverse. Okay. And allows us to just do iterations in a more efficient way rather than using traditional for loops. And let's go through that process now. So here we're going to arbitrarily have a function, right? And then we're going to have now a vector and then apply a function on this vector. One could argue you can easily do this within the for loop, but this makes the actual code more readable and then also generalizable to more sophisticated cases, as we'll soon see. So I'm going to square each number. Okay, so I'm taking x and I'm going to return x squared. Okay, x. And then I'm going to square it. And then let's just say we have the following numbers. You know what? I'm going to be a little lazy. I'm going to do 2, 2, 2, 6. Okay, that's a vector. I was supposed to just, provide 1, 2, 3, 4, but that's fine. We don't have to do that. Okay. And then what we're going to do is provide the vector first. Okay, numbers to square. Numbers to square. I wish I had autocomplete in this. Numbers to square, because I wouldn't spell things incorrectly, and then square a number. Haha, square a number. Square a number. Okay. And I'm going to print out my result. And so this is going to save it as, I don't know if in the video I'll eventually do this. Oh, I do it. Okay. Because this is going to be annoying. It gives it to you when you use the map function. This is the per element. My apologies for not emphasizing that. That's me. This is me using the per function. But it gives it to you as a list, and I emphasize using lists, which is, fun and dandy, but ideally you want to be able to store it as a vector. And then, if you need to, you can then use it within a data frame. Okay. So below I have that. So when you use map DBL for double, because you're dealing with doubles, or if you're dealing with a numeric variable, you can then apply map DBL to this function. So you imagine if you're working with strings, you know that for a fact there needs to be a map CHR for character. Okay. So let's go ahead and do that. So then I'm going to put in the same, you know what? Let's play the copy and paste game. Copy this, paste that. Okay, and then finally we can talk about squaring the vector. And now when I run this, I should get a vector. Boop. There we go. So that's that. All right. So then if that's the case, or since that's the case, what we can then talk about is actually applying it to a character. Okay, with characters. And there's no instruction, so I guess I would just, we're going to say hello name. Hello, the name. Kind of like what we did in video, I think that's 11. Right? And then let's say Jameer. Jameer is the main character in my children's book. You can Google that, The Adventures of Jameer, and see a book written by me and my wife, which is kind of cool. Let's say Jimmy, my PhD advisor, and then John, my grandfather-in-law. Okay, again, of course, the first input is going to be the vector in and of itself, and then the function is going to be the second input. What's so a little bit of annoying is that, not annoying, but I'm pretty sure it's not going to have a space. Pretty sure it's not. Let's see. Oh, it does have the space. I wonder why it does that. Interesting. Oh, because I think that by default, separation is equal to space. So if I do this now, no space, space. So that's that. Okay, that's that. So let's make this a little bit more complicated. Now I can iterate over two numbers. Okay? Or sorry, two vectors. So let's say, and you want to do it element wise. Okay, so this is going to be X, and then this is going to be Y, and then this is going to be X plus, guess what? Y. That makes sense. That makes sense, right? And I'm going to do something fun, crazy here too. And as you can imagine, again, they have to be the same length. I'm going to do sequence. I always go off script. Always. I just have an issue. I'll make sure it works. 3 to 10 by 3s. That makes sense. Okay. 3 to 10 by 3s. We'll do that. And watch the next one. I don't have it be the same length. It's so funny. I'm just going to do 10 colon 12. Okay, I think that includes everything, 10 to 12. I don't know, I'm second guessing myself, but yeah, it's fine. So you can we learn a new function today, sequence. Okay, that's cool. And then now the first inputs are going to be those two vectors, and then finally you provide the function. Okay, you provide the function. First numbers, second numbers, and then the actual function name. And then we can then just post sums or print sums. And this should give us 13, 17, and 21. Oh, good. I can add. All right. So the thing is, what's nice about this is that, let's say, for example, you have, I'm pretty sure this is not an example that we have. Let's say you have P number of vectors, and you have a function that you want to apply to all those vectors, those P number of vectors, and then utilize it into one vector. There's something called PMAP. Okay, so once it gets beyond two vectors, you start using PMAP. And so you say in the back of your mind, I don't believe him. He makes too many mistakes. So you can see that these functions do exist. They do exist. Okay. There's some really other cool things in purrr that, like, I honestly get a kick out of. I'm pretty sure you're gonna see this workflow in the next video, recorded at my conference. But we're going to talk about some other purrr related functions. Okay, sometimes you want to call a function not for it to return, but for what it does, like printing a message or saving a file. It's kind of like a side effect. I traditionally haven't used this. I haven't created an estimation algorithm in a long time. But I could see where I would want to use this function if I had to create an estimation algorithm. But that's neither here nor there. I think it's worth still being cognizant that this thing works, right? And what's really neat about this currently is that we're actually utilizing a vector. I mean, we're utilizing a data frame. So let's go ahead and do that. So you have your student, okay, student name, okay. Then you have their final grade, and we just want to print out Ann, Ben's, and Charlie's, and they told me I can print their grade out. That was supposed to be funny. So it's name, and then grade. Okay. Name, grade. Because you're not necessarily printing anything out. You're not necessarily doing anything with the data. You're just printing information. And what's really cool is that, well, I guess it's nothing cool. I mean, it is cool that we can do this. And we're doing it through a data frame. That's what I'm excited about. Okay. And then what we're going to do, and we're going to do this in two ways, actually. We're going to do it one way I don't like. This walk to mechanism, in that we're going to do student data, student underscore data, $sign. Remember, that's for me to extract the variable, and then student data, student data, $sign, final grade, and then apply that function print summary. Does that look nice? Oh, I forgot to put underscore. I'd have been like, what did I do? What did I do? And that's going to be another error. And then finally, if I just run this, we got all the grades. Okay. To me, a more efficient, at least a more aesthetically pleasing way of doing this would be to utilize this thing called an anonymous function. Okay, using an anonymous function. Okay, what I mean by that, I'm just going to delete this because this is the same information. I'm just going to delete that. And then what I'm going to provide it is I'm going to use the data frame, student data. I'm going to pipe it into pwalk. So we don't necessarily know the number of inputs, but it's going to assume based on the information that's given. All right. So this is an anonymous function because we have a tilde here. We're not necessarily naming the function. We're just going to be just anonymizing it using that tilde. That's huge thing to note. The next thing to note is that we're going to then, not arbitrarily, we're going to utilize the period .x to specify the very first column in that data frame, and then specify the next column .y, and it has to be .x and .y. Okay, it has to be .x and .y. So when I run this, oh, that's embarrassing. Okay, I found my error. So come to find out, we don't even need an anonymous function, and I think I'm going to intentionally have to bring up the anonymous function in another video or in class. Because mind you, it's an important concept. But what we could do to make it simpler, and you can modify this in your code, is I got rid of the final grade here. Got rid of that final grade here, and just named it grade. And then since the first two arguments are the same as the data frame, if I were to plug this data frame into pwalk print a summary, it's going to not work. Because it's now utilizing those first two arguments as the appropriate arguments because the names match. Boom, it works. Now my question is, I want to break it. Let's see if I can break it. This would be interesting. This would be nice for us to see this. So let's say if it were to be, let's say, score. I'm trying to think if there's an order matter. So I'm going to do 1 to 3. In this first situation, it doesn't matter because we're extracting name and grade from the data frame. That's why it showed up. But since this is not in order, will it still work? No. So it has to be the name and the grade of that said student. Name and the grade of that said student. Okay, in that specified order. To be able to use the p-walk mechanism. Okay. To do that. It's interesting. Alright, well thank you all for watching this video. Made it a little longer than it needed to be. We can see how utilizing functions in within the map, functions within purrr allow you to do some really novel things, and so that's cool. Thank you.